Mount Rainier has the most glacier ice of any peak in the lower 48, but still, geologists estimate it's lost more than half its total ice since 1900.
A swarm of earthquakes started at Mount Rainier, and a swarm of earthquakes are a grouping of earthquakes that are happening in the same space in close together in time.
High in the mist-shrouded heart of the Pacific Northwest, Mount Rainier stands as a sentinel, a peak draped in white, its glaciers gleaming under the ever-shifting sky. For generations, these ancient rivers of ice have carved the mountain's iconic silhouette, feeding lush forests below and nourishing the waterways that flow to the distant sea. From the bustling communities of western Washington to the wild, untamed backcountry of the Cascades, Rainier's glaciers have long been a source of both beauty and life, a symbol of resilience in the natural world. But now, in the 21st century, a new chapter is unfolding. Satellite imagery and on-the-ground research are revealing a disturbing truth. Beneath their tranquil, glistening surfaces, the glaciers of Mount Rainier are changing at an unprecedented pace. Scientists armed with cutting-edge technology are observing the subtle and dramatic signs of hidden melt, processes that may rewrite what we know about the future of glaciers, not just on Rainier, but across the globe. Satellite images, newly analyzed, suggest that the melting is not confined to the sunlit slopes or crumbling ice cliffs visible from afar. Instead, it is also happening from below. Atmospheric shifts, volcano-driven geothermal energy, and evolving patterns of meltwater are reshaping the fate of these ancient frozen giants in ways that challenge our most basic understandings. What secrets lie beneath Mount Rainier's icy facade? How has a warming climate unleashed invisible forces that now threaten to undermine the mountain's timeless glaciers from within? And what lessons does this unfolding story hold for the fate of ice sheets in the farthest corners of our planet? Join us as we venture beyond the surface, delving into the hidden drama of Rainier's glacier melt, guided by satellite vision and scientific discovery. Are we witnessing the first signs of a profound transformation whose consequences remain to be fully understood? Mount Rainier and its glaciers, legacy of ice and time. Mount Rainier rises over the landscape like an apparition, its summit reaching 14,410 feet into the cloud-laced skies of western Washington. The volcanic peak is a magnet for legends and a lifeline for surrounding ecosystems. Its glaciers, a reservoir of fresh water, a sculptor of valleys, and a barometer of the region's changing climate. These vast, flowing fields of ice have been forming, retreating, and reshaping for thousands of years, bearing silent witness to geological upheaval, ancient weather, and the evolution of life itself. Carved by ancient forces, Rainier's glaciers once spanned vast swaths of the mountain. The mountain is home to more glaciers than any other peak in the lower 48 states. They are the source of crystal-clear rivers, carving deep canyons as they flow outward in all directions. The Nisqually, Emmons, Carbon, and others, each a mighty tributary of meltwater unleashed from above. The story of Rainier's glaciers is not just a story of ice, but of motion, transformation, and survival. Glaciers expand during cold, snowy winters, then recede in the grip of warming summers. Their retreat and advance are the heartbeat of the mountain, an endless cycle that connects high-altitude snowfields to sea-level estuaries. The ice itself is alive, cracking, flowing, and shifting, a relentless force sculpting Rainier's rugged slopes. Imagine standing at the foot of the Nisqually Glacier, where centuries-old ice grinds slowly downward, a massive, living river that can swallow trees, carve stone, and release bursts of roaring meltwater in spring. Hikers and climbers on Rainier's slopes often describe a sensation of both awe and humility, dwarfed by the scale and timeless movement of the glaciers. Ancient moraines litter the lower valleys, silent reminders of era after era when the ice advanced only to pull back, revealing land forever altered in its wake. Yet, in the last several decades, these glaciers have begun to shrink at a dramatic rate. Images captured from above tell a stark tale. The The broad tongues of glacier ice have thinned and shortened, exposing raw, naked rock where only snow and ice lay before. A warming climate has already eliminated 3 of the mountain's storied glaciers, slices of the past lost, perhaps forever, to relentless heat. For those who have visited Mount Rainier year after year, the changes are heartbreakingly visible. Where children once scrambled up tongues of snow from the parking lots, now there are stretches of gray scree. Scientists walking along the glacier's edge find fresh outcrops, not seen since before the Industrial Revolution, making visible the scale of transformation wrought in mere decades. Seasonal snowpacks arrive later and vanish earlier, reducing the mountain's once robust supply of meltwater needed for the forests and communities below. But glaciers are not static monuments. They are geophysical systems. Their very survival vulnerable to forces both visible and hidden. Now, for the first time, advanced satellites and remote sensors have given scientists an unprecedented window into how these glaciers are changing, not simply above, but below. What previously unseen processes are unfolding beneath the blue-white shield of Rainier's glaciers? Is the greatest threat not at the surface, but lurking deep beneath the ice? Satellite eyes, revealing the unseen meltdown. For centuries, the secrets of glaciers remained locked within their frozen depths, shielded from curious eyes by forbidding crevasses and avalanches. Today, however, satellites watch Earth's high places from hundreds of miles above, their cameras and radar mapping every contour, every spectral signature, every subtle shift. The results are nothing short of astonishing. Through the meticulous work of researchers such as Hedy Silvestri, satellite data is now being harnessed to track rapid changes on Rainier's glaciers with a precision never before possible. High-resolution images captured in succession over days, months, and years unveil not just the obvious, receding termini, shrinking snowfields, but patterns of thinning, structural weakness, and shifting flow rates within the glacier itself. Using instruments such as synthetic aperture radar, SAR, and interferometry, scientists distinguish even minute changes. SAR, for instance, bounces microwaves through the ice to map not just the surface, but the substructure, allowing researchers to see if ice is accumulating, compacting, or being eroded below. Each new satellite pass peels back another layer of the glacier's story, revealing pulses of meltwater pooling in pockets or vast hollows where ice is thinning beneath the outwardly unbroken surface. The 2024 analysis of satellite imagery over Rainier provided an unsettling view. Where once the glaciers appeared as stoic rivers of ice, new evidence reveals zones of accelerated melt and collapse. Crevasses have deepened in once solid ice fields, while sun cups, those intricate honeycomb depressions in the firn, have grown more expansive, their boundaries eroded not only by sunlight, but by unseen currents below. It is here that the satellite eye becomes a revelatory force. Fluctuations in ice thickness are mapped with radar altimetry, exposing subsurface channels where meltwater flushes through the glacier's heart far beneath the surface. These dark, winding veins of water, turbulent and persistent, are carving new pathways, weakening ancient layers of ice from within. In some places, entire sections of ice have slumped downwards, the surface collapsing as the glacier's underside is eaten away by warmth and water. Satellite tools also allow scientists to stitch together time-lapse movies of change, watching the ice and land evolve over months and years. They've watched cracks spread, crevasses widen into chasms, and meltwater lakes form and drain in a matter of days, scarring the glacier's surface and undermining its internal structure. Perhaps most striking is that from above, the changes can seem almost invisible, but from within and from below, the story is one of tumult and hidden danger, a melt that creeps, seeps, and undermines, largely unseen until it is suddenly, dramatically revealed in the catastrophic loss of glacial mass. How can something so ancient, so seemingly immutable, change so swiftly and so quietly? Are we only beginning to glimpse the true scale of the the transformation unfolding inside the world's great glaciers. The melting from below, forces in the shadows. Glaciers have always been vulnerable to the touch of sunlight and warm winds, but a less visible enemy now gnaws at their foundation. It is a force that operates in darkness, flowing from beneath the cold, silent heart of the glaciers themselves, a melt from below, as ominous as it is complex. Decades of research have taught us that the surface melt, though dramatic, is only part of the story. Scientists now predict that substantial glacier loss may also come from underneath, shaped by a combination of warmer ground, shifting groundwater, and geothermal processes linked to Rainier's status as an active volcano. But how does a glacier, thousands of feet above the nearest ocean inlet, succumb to forces from below? The answer lies in the hidden labyrinth beneath the ice. Recent discoveries highlight the role of geothermal energy radiating from Rainier's volcanic core, a steady warmth capable of destabilizing thick masses of ice resting directly atop fractures in the bedrock. This heat, invisible to the naked eye, is now being detected by satellites capable of tracking subtle thermal fluxes. The story does not end there. Scientists are studying how changes in rain and snow patterns, possibly accelerated by human-driven climate change, introduce more liquid water into Rainier's glaciers. As the climate warms and summer snowmelt increases, water seeps into crevasses, entering the glacier's interior and speeding up melt at the base. There is also growing evidence that, as permafrost and underground ice thaw, groundwater channels once sealed tight begin to flow again, becoming conduits for warmer water to infiltrate beneath the glacier, a process scientists are seeking to better understand. Researchers have published data demonstrating how shifts in regional rainfall and snowmelt can send pulses of liquid water directly into the subglacial system beneath Rainier's thickest glaciers. In response, networks of microchannels widen and multiply at the ice bedrock interface, amplifying the melt rate and potentially compromising the glacier's structural integrity. What makes the situation on Rainier particularly alarming is the way that years, or even decades, of slow subglacial melting can remain hidden until the moment of collapse. Surface crevasses widen and deepen, while the ice above hollows beneath its own weight. Satellite mapping has exposed zones where the glacier has become separated from its original bed, hovering above pockets of water and slush, the ancient ice sheet literally melting from the bottom up. Some scientists also study possible local effects of volcanic gases escaping through cracks in the earth beneath Rainier, which could affect ice melt locally due to subtle heat and chemical interactions. The combination of these factors paints a picture more complex than simple air warming, one in which local geology, global climate, and subglacial processes all converge beneath the ice. Are these processes unique to Rainier, or do they hint at a new chapter in the story of glaciers everywhere, a warning of what is to come as both heat and water invade their most protected interiors? Echoes from afar, lessons from Antarctica and beyond. To truly appreciate the significance of Rainier's subglacial melt, we must look to the coldest places on Earth, especially Antarctica, where discoveries are rewriting the textbook on glacier science. The world watches as Antarctica's vast ice sheets, until recently believed to be stable, are found to be melting from below at astonishing rates. The parallels to Rainier are striking. Aerial surveys and robotic probes beneath the Thwaites Glacier, a colossal river of ice flowing into the Southern Ocean, have shown that warm ocean water is not only dissolving the glacier from the edges, but is also penetrating miles beneath the sheet itself. Massive hidden cavities have formed under the ice, their walls collapsing and reforming as melt rates accelerate. These findings, together with satellite data from Rainier, suggest a profound truth. In a warming world, glaciers everywhere are vulnerable to processes beyond surface weather. What can Mount Rainier teach us about these global shifts? The answer lies in patterns and timing. As satellites reveal the labyrinth beneath Rainier's frozen skin, scientists recognize similar features across continents, a choreography of meltwater, heat, and dynamic change. repeating again and again. The mechanisms uncovered in the Cascades reflect processes in polar regions, highlighting how regional studies can illuminate worldwide risks. These links between distant glaciers point to crucial global feedback loops. As meltwater from Rainier and other mountain glaciers flows into rivers, it influences environments from temperate rainforests to coastal regions. In Antarctica, enormous volumes of meltwater can slow or alter oceanic currents, which in turn impact atmospheric systems and climate patterns far from the pole. The implications are urgent. Scientists now warn that as Antarctica's ice sheet continues to lose mass, the repercussions could circle the globe, raising sea levels, altering currents, and reshaping weather. While Rainier is not threatened by oceanic encroachment, its story echoes a broader warning. Glacier melt from below is emerging as a global challenge with ripple effects, felt well beyond mountain valleys. The lesson is clear. If we overlook the warning signs in Rainier's satellite images, we risk missing similar threats developing elsewhere. Threats that could, over decades, redraw coastlines, disrupt ecosystems, and impact communities worldwide. Voices of science, warnings, and wonders. To witness the raw data on Rainier's glaciers is to stand at the boundary of knowledge and mystery. Scientists like Heidi Sevestre issue cautious warnings, but also describe a sense of awe. They know that glaciers are more than indicators of climate. They are dynamic systems, repositories of ancient weather and geological change, sensitive to every tick of temperature, every influx of water. What satellites reveal is not just loss, but transformation. The intricate processes of melt and flow exposed beneath Rainier's surface tell of danger, but also resilience and adaptation. Not all glacial change is instantaneous or catastrophic. Some glaciers oscillate, ebbing and flowing with patterns as old as the mountain itself. Yet, the accelerating loss and the novel path of melting from below departs from historic rhythms, a sign that the past may be a poor guide to the tumultuous future unfolding now. Many voices in the scientific community urge us to see these revelations not as the closing of a chapter, but as the opening of a new era in climate science and mountain stewardship. The data gathered at Rainier is not only a warning, but also an opportunity, a trove of insight that is driving new modeling systems, smarter resource management strategies, and the development of real-time early warning networks. With greater understanding comes increased potential for adaptation, whether by adjusting water policies for towns and farms downstream, informing emergency planning for floods, or pushing for action to address the root causes of warming. It is critical, as scientists argue, not to reduce the story to mere statistics or inevitable decline. Within each layer of data lies hope for insight, for innovation, for a new kind of stewardship informed by the latest revelations. Just as satellites teach us to see the previously invisible, so too can newfound awareness inspire action and preparedness. What then are we to do with this knowledge? Are we passive observers of an unfolding loss, or do we bear a deeper responsibility to respond, adapt, and perhaps even reverse what once seemed inescapable? The story of Rainier's glaciers is still being written, and each new discovery brings more questions. Where do we go from here? The unwritten future. As we stand at the edge of understanding, the fate of Mount Rainier's glaciers appears both precarious and profound. Satellite images, once simply tools for measurement, have exposed the scale and complexity of the changes unfolding below. The glaciers, once thought nearly eternal, are now known to be deeply vulnerable, not merely from above, but from within, melting in silence until the evidence is undeniable. Yet, there is power in this revelation. The newfound knowledge does not mark the end, but a beginning, a summons to deeper inquiry, sustained vigilance, and collective action. The story of Rainier's glaciers now joins the larger narrative of planetary change, an intimate case study that resonates from the highest peaks of the Cascades to the vast emptiness of Antarctica. Will we heed the warning signs etched in ice and stone? Will satellite eyes, scientific minds, and renewed commitment forge a new path forward, one that honors the legacy of glaciers while confronting the realities of a rapidly warming world? Or are we witnessing, in real time, the retreat of ancient wonders, lost to a future we have only begun to imagine? At the heart of these questions lies the mountain itself, silent, imposing, and ever-changing. Its glaciers may shrink, reform, or vanish, but the quest to understand, preserve, and reimagine their story continues. What truth do you see when you gaze upon Rainier's icy slopes? Fragility, warning, or hope for renewal? Could these images, both shocking and compelling, become the catalyst that sparks change across the globe? Let us know your thoughts in the comments below. And if you're eager for more explorations of the wild, mysterious forces shaping our world, make sure to subscribe and join us for the next journey, where we'll delve even deeper into the frontiers of Earth's hidden marvels. Turn on notifications so you never miss a story that could change our understanding of the planet and ourselves.